Example: in a factory which manufactures bolts, machines A, B, and C manufacture respectively 25%, 35%, and 40% of the bolts. Of their outputs, 5, 4, and 2% are respectively defective bolts. A bolt is drawn at random from the product and is found to be defective. What is the probability that it is manufactured by the machine B? Solution: let B1 denote the event that the bolt is manufactured by machine A, B2 denote the event that it is manufactured by machine B, and B3 denote the event that it is manufactured by machine C. And E denote the event that the bolt is defective. Now we see that B1, B2, B3 are mutually exclusive and exhaustive events, and hence they represent a partition of the sample space. The event E occurs with B1 or with B2 or with B3. Given that probability of B1 is 25%, probability of B2 is 0.35 and probability of B3 is 0.40. Probability of E by B1, that is probability that the bolt drawn is defective given that it is manufactured by machine A, is 0.05. Similarly, probability of E by B2 is 0.04 and probability of E by B3 is 0.02. Hence, by Bayes' theorem, we have probability of B2 by E equals 28 by 69. Example: a man is known to speak truth 3 out of 4 times. He throws a die and reports that it is a 6. Find the probability that it is actually a 6. Solution: let E denote the event that the man reports that 6 occurs in throwing of the die. S1 denote the event that 6 occurs and S2 denote the event that 6 does not occur. Now probability of S1, that is 6 occurs, is 1 by 6 and probability of S2, that is 6 does not occur, is 5 by 6. Now probability of E by S1, that is probability that the man reports that 6 occurs when 6 has actually occurred on the die, is equal to probability that the man speaks the truth, is 3 by 4. And probability of E by S2, that is probability that the man does not speak the truth, is 1 minus 3 by 4, that is equal to 1 by 4. Thus, by Bayes' theorem, we get probability of S1 by E, that is probability that the report of the man that the 6 has occurred is actually a 6, is equal to 3 by 8. Example: a company has 2 plants to manufacture scooters. Plant 1 manufactures 70% of the scooters and plant 2 manufactures 30%. At plant 1, 80% scooters are rated as of standard quality, and at plant 2, 90% scooters are rated as standard quality. A scooter is chosen at random and is found to be of standard quality. Then what is the probability that it is coming from the plant 2? Solution: let E denote the event that plant 1 is chosen and F denote the event that plant 2 is chosen. A denote the event that scooter is of standard quality. Probability of E equals 70 by 100 and probability of F equals 30 by 100. Now probability of A by E is 80 by 100 and probability of A by F is 90 by 100. The required probability is probability of F by A. Hence, by Bayes' theorem, we have probability of F by A equals 27 by 83. Example: A doctor is to visit a patient. From the past experience, it is known that the probabilities that he will come by train, bus, scooter, or by other means of transport are respectively 3 by 10, 1 by 5, 1 by 10, and 2 by 5. The probabilities that he will be late are 1 by 4, 1 by 3, and 1 by 12. If he comes by train, bus, and scooter respectively, but if he comes by other means of transport, then he will not be late. When he arrives, he is late. Then find what is the probability that he comes by train. Solution. Let E be the event that the doctor visits the patient late, and let T1, T2, T3, and T4 be the events that the doctor comes by train, bus, scooter, and other means of transport respectively. Then probability of T1 is 3 by 10, probability of P2 is 1 by 5, probability of T3 is 1 by 10, and probability of T4 is 2 by 5. Probability of E by T1, that is, probability that the doctor arriving late comes by train, is 1 by 4. Similarly, probability of E by T2 is 1 by 3, probability of E by T3 is 1 by 12, and probability of E by T4 is 0. Now since he is not late if he comes by other means of transport, that is why probability of E by T4 is 0. Therefore, by Bayes' theorem, we have probability of T1 by E, that is probability that the doctor arriving late comes by train, is equal to half.